Alright, so today we're going to be doing some soldering, but first I also need to repair some of the lines that were damaged when I took the ceiling down. So what I've got to do is crimp a couple of extra cables into the currently existing set, and then we'll solder those to the LEDs. I've already done one. It's sitting right here. Soldering's pretty easy. There's several different ways you can do it. The most effective way is to heat the solder filament and soak, if that's the right description, the actual cable, and then the copper wiring, and then once you've got a little bead of that filament on there, heat it up again and melt it to the point on the back of the LED that looks like that, one of those guys. Something to have handy is a crimper tool. I don't actually have a crimper tool. I've been doing this long enough that I don't have to worry too much about that. But what is a good idea is to make sure that your cables are crimped together and not just taped with electrical tape. Now, there's several places on the bus where all I did was use electric tape, but I do that very sparingly, and I do it in places that I know I can get away with it. I always recommend doing it the right way every time, and this is going to create a solid connection. What I will also do is you want to test the back, make sure it's crimped correctly, but then what I'll do is I will send electrical cable around that as well. This one's actually been frayed a little bit, so I'm gonna tape that up first. It's actually kind of damaged. I probably should cut that back and do another one. I'll just go ahead and do that. Practice what you preach. Be safe. This is the cable here that's frayed. You can tell I made myself a little duct tape band-aid because I slit myself open this morning. In any case, that's the frayed cable. You just want to stay away from anything like that. I mean, that touches a ground up there somewhere. Sparks, or you're going to start blowing fuses, and you're never going to figure out why it's blowing until you pull all the panels down and figure it out. Save yourself the hassle and just replace frayed cables. You should also have a fire guard. Let me see if I can find one. This stuff right here, it just goes around the outside of a cable. Not only does it organize them inside that channel there, it also it's not fire proof, it's fire retardant. And what'll happen is if there's a short somewhere and your wires heat up, this is going to protect anything else from catching fire in there to a certain degree. And that's an interesting play on words. Also, I've got my soldering gun hanging against a metal area, so it's not going to touch anything that's going to start flame or melt or anything like that. And I also keep it away from its own cable. Normally there's a stand that you can set those in, but I lost mine. So I hang this next to a metal shelf that it's not going to melt anything. Speaking of being safe, you're also going to want to make sure that your cables, all of your wiring, is unconnected. Totally unconnected to any battery or power source before you get into doing this stuff. You're also going to want to make sure that once you do power it up, it's grounded through the normal channels that it should be grounded. And then, on top of everything else, you'll also want to make sure that you not only have extra cables, but extra cables that are the exact same color as the cables that you're patching into. So I've got black and gray cables coming through the bus, so I went ahead and took an extra set of black and gray cables to make this connection as well. And that isn't necessarily going to help you in the immediate, but in the long term, when you are wiring other components into the system, you'll be able to tell which is which and what goes where and all of that stuff simply by chasing down those lines. And you wouldn't be able to chase down those lines if you didn't at first tie them all into the same color scheme. All right, so this is the filament right here. Also, another thing you're going to want to do is hang your There's two things you should know when working with this stuff. Number one, this is over 400 degrees, 450 degrees or something like that, so it will mess your business up. Don't think that it won't. Don't make the mistake of playing around with this thing and not judging it and respecting it with the dignity it might require. Second thing, the chemical, when it burns, the actual fume that comes out is known in the state of California to cause cancer and birth abnormalities, and they're pretty serious about that. Try not to breathe that stuff in. Make sure you're in a well ventilated area, all of that stuff. When I do this, I kind of hold my breath, wait for stuff to clear, blow out, make sure the air is kind of like ventilated. Plus I got windows open, doors open, there's a breeze blowing through. I should make it to the apocalypse. So now that there's this little silver bit on each one of these, it looks like it's kind of been dipped in, you know, Terminator 2 goo. That's the stuff that you heat when the terminal is touching it at the same time, and it'll line itself up right with that cable. So I'll show you the close-up of this one again. You can see that back section there. These two terminals are what that's going to look like. Now this one's got a little nugget on there that I could actually tighten up my solder a little bit. I don't want that catching on anything when it's up there. Well, that looks a little better. So that's going to be a nice continuous connection there. You'll want to spread the connection points, connection pins a little bit out, just to give yourself some room to play with. But you don't want to bend it too much because that will break right off. And another thing to note is that these are not polarity sensitive, so you don't have to worry about hitting one on the positive and hitting one on the negative. It'll light either way. Now, as you're doing this, there's a couple of things you want to keep in mind. Number one is the wire, as it goes back from the place that you're heating it back to the source, it gets hot. It's metal. It transfers heat, so that's gonna get warm. Don't let that freak you out. It's not gonna melt through the rubber unless you hold it there for a long time and you're really just kind of tapping at it. The second thing you want to note is this stuff heats up and becomes a liquid. So if you're doing it above yourself, don't be underneath it. Make sure your feet are not in the drop slash splash zone where this stuff could hit you. It will suck. It'll go right through your socks. It'll be a permanent metal piece of your shoe. God forbid you're barefoot when you do this. It's going to be pretty painful. So, all right, so that's that one. I'm going to go ahead and solder the rest of the lights in. There are a total of 10. And what I'm going to do after that is wire the source with 2 switches. I'm going to bring a switch up to the main panel, which is right by the door here, and then have 2 switches so that I can, they're alternating. So the ones with this white piece of paper on them, and this one originally had a white piece of paper as well. The ones that are marked white are on one switch. The ones that are not, that do not have a marker, are on another switch. So when I flip one set on, it'll be half the amount of light. When I switch another set on, it'll be full blast. And so I did that so that if you know, you kind of have like a nice ambiance at night if you don't want to light the whole place up, or if it's really dark and you really need to find something, you can have all the lights on at the same time. If that's not enough, when I'm done, I'll probably also connect a rope light, kind of like an LED rope light somewhere. I haven't actually done the trim yet, so I might do an offsetted trim with the rope light coming underneath it so that it'll kind of bounce off this white beadboard, which will be nice. We'll see how it goes. All right, so as you can see, I have soldered and connected and mounted all of the covers for the lights, and half of them are on right now, so it's plenty of light. And when the other half come on, it's like daylight in here. These things are pretty awesome. I'm okay with the little amount of heat that they give off. They do give off a little bit of heat, but it's okay. It's not alarming. Soldering went pretty well. I reinforced the solder with some separating electrical tape between the two connecting points. It's not necessary, but you never know if like a metal filament, you know, floats around up there. You kind of want to take as many precautions as possible. The more time you spend on it now, the less time you're going to spend on it later, and it's kind of a maintenance thing. So what I'm doing now is I'm about to mount the switches for the lights, which will turn half of them on at one time and half of them on at another time. And I've mounted a, not even 3/8, like 3/16 beadboard, flat board, not quite beadboard, but up against this flush area where I've made the metal divot flush so that I can later put a wall post there. And I'm going to go ahead, I've duct taped my switch points in there, measuring them over to the area that I wanted them over, so they're nice and even. I mean, I can eyeball it and it really wouldn't matter. I could put them next to each other, but what I went ahead and did is put them on top of each other. And hopefully they're up and away out of the walkway enough. I put them pretty high and set back, so that if you're walking in with, I don't know, something over your shoulders, carrying something in, you won't like smack it, bash it, whatever. And eventually the wall area is actually going to come over, so there'll be a secondary kind of protection from that being bumped. And I'm about to drill it's probably a little bit bigger than a 3/8 bit hole where the neck of the switch is going to go in. Screw that down, connect it from the back, test it. If it works, great, that's awesome. It's running a very limited amount of electricity from the DC batteries direct, so I don't think it really needs any kind of a surge protection, but I'm going to run both of those through the fuse bus, which is right here. That's going to mount to the wall. This terminal here is going to be the positive end, so this is going to be the hot end. Send a direct line down to the battery, and everything else goes from these connecting points out to their components or to the switch and then the component, and there's going to be a breaker in between each one. Each one of these lines here is a breaker, and they'll light up when there's actual power going to it. Not when the switch is off, but when the gate is closed. So when the switch is connected, that'll light up and indicate that there's power going through it. I don't imagine that most of the appliances are going to be more than 7 to 10 amps, but the water pump under the sink, as well as the winch in the back, probably going to take 30 amp fuses. I'll test that out, see if, I mean, I'll blow through a few, I guarantee it, trying to find out which one's which, just to be safe. But once I find it, I'll mark that on the outer cover. And the outer cover is floating around here somewhere. I haven't really cleaned up since I started working, so but anyway, on the cover of the fuse bus, I'll mark individually which one is which and which fuse level, which amperage level it requires. So Once that's done, everything I have right now that is connected is fine. And the only thing that these are going to be controlling and covering are the DC powered items. Breakers for the AC components exist within the inverter charger itself, so I don't really need to worry about that too much. It's got a main 30 amp coming off the positive end of the terminal in the battery bank. It's grounded, and it's got the individual GFCI outlets ×2 on the inverter front, on the face of the inverter. So should be all covered after that. So yeah, let's get to it. So the bus is going to sit roughly here. Power is going to go from these two of these terminals over to here, and then the other end is just going to go to the ground block, which will be right here, and the ground block is connected to the battery. So it's going to be really simple and easy. Let's get it done.
Thanks for watching. I hope you liked it. If so, be sure to subscribe and give me a thumbs up. Construction on the tiny home is actually complete, so visit kyleodonnell.com/blog to binge watch the build. You'll not only read my personal journals during construction, you'll also see videos covering everything from solar installation and transforming bedrooms to wiring your electronics and off-grid plumbing.